Yeah, so today things get a little bit more interesting. We use again the same methods for communicating with server, but now we try to communicate with more servers to see what kind of features we can use in our app that others would lend us functionality for. So let's begin by looking more at what Google has to offer. For that, I have made here a new web page, a new project, and our addition from yesterday is still working. So I'm going to keep it as an example, call to my own server, and the response for adding two numbers. And any new update that we will add, I will add it here. So this page will contain calls to many different services, and we will try to demonstrate how they work. So the Google services that we will be looking today are not from the Android API or iOS or from the web API. They are from this last one, the web service APIs. So these are server-side APIs that you call, and you can get response if you are using the Google map or not. So it doesn't matter if you use the map in your application. It's just an HTTP request that you will send to them and read the response. And we will be looking at two different examples, I think. So many others here if you're interested to check them out. But I thought it's quite interesting to check the Timezone API. So Timezone API, what it does is that it gives you the offset data. So how is the difference, time difference from this, I guess from this UTC time? It includes the daylight savings and other factors. So finding out the time for a location is not a very simple thing to do. It's difficult. It depends on the country borders, on political reasons, and also this daylight savings that now some countries are using it, some countries don't use it. How do you know? You either make a very big database and you read the news every day to see if something has changed, or you call some API like this that tells you more or less for a given location and a given timestamp what the time at that place is considered. So this timestamp is the same all over the world. Is I'm not sure if you know, but this Unix timestamp. So this Unix timestamp is, I believe, number of seconds that has passed since 1970. I think so.
January.
Yeah. So first of, let's see. So this timestamp. Yeah. So the count starts at 1970, January 1st, thank you. And it just counts seconds or milliseconds or whatever. And we have been using it already for many times when working with this tracking app, but I forgot to mention until now. So this is regardless of time zones or location. It's just a time measure. And let's see how it works in practice. Also, note here that API key is needed again. So the Google and most of these things that we are using today, you will need to make an account for them and get a key. So I'm not going to demonstrate that part because it's the same as getting the key for Google, which we already have seen before. So today a little bit different. I already have the example code here, and I'm going to one by one add the different functionality in our program. So I'm going to add this get time zone. I'm going to save the file, and I'm going to refresh this page. to see that it doesn't update. Just a second. Okay, there was the cache problem, so opening this developer tools now also clears my cache. So what it says is it's 2-hour offset at this location. This is just some location in Finland with 62 degrees latitude, 28 degrees longitude. And my function get time zone, it has 2 parameters, latitude and longitude. It has a key, okay, it's using a key, this Google Maps API key, and it's forming a GET request, okay, exactly as in the this example here. So it's the same request from here, but my variables, my values for the degrees and the timestamp are now coming from the parameters of the function itself. So if I'm going to call the get time zone with different values, it's still going to take the current time, but this get time method is in milliseconds, so the API requests it to be in seconds. I'm dividing by 1000 here and I'm rounding it up. So maybe a little bit confusing what is happening. But essentially what I am doing is I am creating a string that contains a dynamic link exactly like the one that you see here, but with changeable properties from this parameter, and the time is going to change. And then the function we saw yesterday, I'm going to make a get request. The request is here, and the output when it completes. So this function will trigger when it completes, when this request is done. It's going to write. Okay, it's going to first parse this output, the string output, and it's going to append this offset to our text here. So this time zone at the location has some offset. Now we will talk more about this. I will explain now more. Let's analyze really what is happening here with the developer tools. So this is a very useful tab here. It's called Network. This tab will teach us more about what calls we are making to outside services. I'm going to refresh this page and keep an eye on what's happening here in this section on the right. So, okay, very quickly, 2 things appeared. First one, if we check our headers, it is our request type add numbers. So it's adding the 42 and 29 numbers. This is our form data, our JSON data here, and it's being sent to our server, our Lamad server here. So you can see in the tooltip on the mouse where it is going, and the response for that is also here. So this is the input, and the response server says 71. So actually here I'm parsing just this number from the result JSON. There's also this preview button, very useful. It does the same thing as our JSON parser from yesterday. It makes it a bit more readable, this output in this object notation. We will see better here in the second one. So the second one, it is this get request. Location is here, timestamp is here, and the key is here. So these are the inputs for the request, and the response actually has more information, but I'm only printing this raw offset. If you check my code, I parse the string output, which contains all the result, and I'm keeping just the raw offset component from there in this print. but more information is there. I'm not sure what all of them are. Status means that it worked correctly. Some time zone information, and also available here. And again, this preview shows the string in object notation. So these developer tools, similar ones exist in other browsers, but I think they are very useful. I prefer these ones in Chrome at least. Okay, is there any questions so far? So now we are asking Google for help. We are not asking anymore our own solution. So we already started asking someone else.
Yeah, one question about the is this a encrypted connection to the Google server?
Yeah, let's see. So, good question. It is a secure connection because it has this HTTPS in the beginning. If it has this, then it means that the connection is secure. Right, and if I call it here again with different values, okay, you might not know, but Romania has the same longitude as Finland. It's just more south. I could refresh now the page, and I'm going to get 2 time zone informations. Apparently, it's the same. It's the same thing there. But if I read the response from the one at 45 degrees latitude, oh, yeah, it's going to say that it uses Bucharest's time zone. So, nice little thing to know that I don't have to reset my time when I come here. Okay. But where are these locations? So Google has a geocoding service. If we go back to the main APIs here, we will also experiment with this. So we saw the time zone, but we can also check the geocoding. We already saw Google geocoding embedded in the Google Maps when we had Superman moving on the map, and then at some point we pressed where he is and we found out the address, the name of the address at that location. But Google has a geocoder that works also as a service. Now, one small thing here is that I'm only teaching part of these services, so you can do a bit more with them if you read these pages. But we just do an example with each. So, yeah, so this geocoding service, I think we can just look at my code here. The same location as before that we used from Finland, but let's find out where it is, like does it have a name or something. Similar, we have latitude and longitude as the input, and the key, this API key is also needed again. And the address is different, so now instead of asking for the time zone API here, we are asking for the geocoding API. So very similar, and we are specifying that we want JSON, the JSON API. Google has also XML and some other options, I think. And the same thing, a GET request. And we parse the output and we format the output there. So I'm going to save the file, run our example, and now it says geocoding this location, and it's this run 20 in Rantasalmi in Finland. So somewhere there. Thank you. Yeah, so the location now also has a name. Of course, I could call this for our new location, this location in Romania. And unnamed road in Romania. So I didn't really check any of these locations first. It's probably some very small country road somewhere. Google doesn't have the information there, but at least it knows the country is there. Right. Do you see something strange happening here? Anybody sees anything strange with this output? It starts with geocoding, then adds some numbers, then some time zone, then geocoding again. Even though my code says add the numbers, do the time zone, do the geocoding. So why is this a different order? And now if I refresh, order changed again. Sometimes it changes, sometimes it might be the same, but so what is happening here? If we look at this network tab again in our developer tools, there is more information here. There will be timing information. So this says that it took 76.47 milliseconds for us to get the time zone. So this time zone information for Finland, and 74 seconds to get the time zone information from Romania, 9 milliseconds to get the address in Romania, and 6 milliseconds to get the address in Finland. And notice here that the content download and this waiting, like how long does it take for Google to figure out the address and how long it takes to download the content. So this content seems to be more important here. The reason is, I'm just saying here this formatted address in the result, but if I check the full response, Google gives me a lot of things in my answer. So I'm only keeping from this result this formatted address component. If you check my function here, I'm only printing the formatted address there. But Google has more information. For example, it can tell me the different components. This is the commune name, so it does know something. This is the county where it exists, and some other information like here seems to be the bounds of the region, like how far can you go north and south, and still be in that region. And yeah, so many different things here could be useful for somebody else, but we just keep it as an example. And in Finland the same, so street level information, number information, country information, and the same kind of borders everywhere. So because this amount of information that we are downloading is quite big, even though we use just the formatted address, then that is why in the timing we have this blue piece that is slightly bigger than in the time zone information, where I remind you response is just this, so it's smaller response. So because of that, it seems like the geocoding is faster. So I remind you again that time zone queries were 100-something milliseconds, and the geocoding were 8 milliseconds. So this download is still very fast. It's just slower compared to the waiting time. So it's about 10 times faster to do the geocoding than to do the other one, which means that on average they will be at the beginning, but it's not necessarily the case. You don't know how Google works, really. You don't know how it prioritizes these services. It may take longer, it may take less. Here they seem to be almost real time, but you should always consider using some progress indicator, telling the user that something is being done, wait for it to give you the answer. Okay. So 2 examples from Google, and I think we will stick with that. And we can move on to something called Open Weather Map. So this we will use to get weather information. Yeah.
Why was the add number so slow?
Which number?
The add numbers, it's not the class you were calling first, and it's a lot closer than Google's?
This one.
Yeah.
I think the reason is the connection. I'm using Wi-Fi connection here. I'm not connecting. Yeah, I know what you mean. If I would run it from this computer, I think it would be instantaneous. Instantaneously, I think these numbers will be much smaller. We can try that, I think, at the end. But because it uses Wi-Fi, I'm not sure where the provider for the Wi-Fi is coming from. So this is not on the same intranet anymore as our app. And Google is just so good, apparently, that that even our call, which is right here, is slow. Or maybe my addition is so slow that.
Excuse me, is that the total time?
Yeah, this is the total time.
Yeah.
And these other numbers also mean different things. But very good question here. I don't really know how to explain. But let's see out of curiosity. So let's take a small break here and change to this other computer. So now I'm using the computer in the classroom, which has a cable connection, and I think is connected to the intranet as well. Okay, still pretty slow. Yeah, but if you noticed at the beginning it was fastest. It was in the top one. Now it's getting lower. I think what is happening now is that Google figured out that I'm asking it questions. So it somehow prioritizes my computer because it's expecting more questions to come from me. These are just assumptions, but first time I opened it on this computer, this was the first one. I'm curious if incognito mode might have some effect here. Yeah, so incognito, new session, seems again we are faster. How much? Let's see, one more time. So opening developer tools on this other computer. This XHR contains these requests, so our own request is still the same speed as the other one, so I was wrong to think that changes much. But the other ones are longer. So even these geocoding that were about 9 milliseconds are now slower. But if I refresh, then it seems like already one higher decrease. So I don't know how they work. Then this is my lesson to you. It seems like the same request takes less time after somebody finds out that, okay, this is a new session, but it already called a little bit. So things for you to consider. It might affect in mysterious ways. Yeah, so it seems like Google is just so powerful that it has servers everywhere, and this cloud system is pretty efficient, but more efficient than calling my slow method. Yeah, just, I don't know. They are doing it. Okay, going back here. Weather, yeah, so weather information. Okay, so I have here another example, get weather in city, in Kuopio. The weather API, okay, let's demonstrate that. So Kuopio weather, overcast clouds. Jarmo?
Yeah, that's true.
Ah, okay, good. So So now we can find out, and probably in Joensuu, it's, I believe, overcast clouds, clear sky, so it's a bit uncertain what the weather is like, but no, sorry. Because of the way I do the printing here, okay, I don't think it's clear sky, but who knows where in Joensuu this is checking. Joensuu is a big place. Let's put back Kuopio. I can't put both of them. It somehow combines the outputs from both of them here, and yeah, I wrote the code quite quickly and didn't consider that I might experiment with both there. So let's look how this one works. It's a different service. It's this open weather map service. It gives you many different things, including an API. So this API will again have a key that you need to sign up for, and it will cost, but some of the things are free, like what I'm using now, and I'm using this current weather data API. There are many other ones with the forecast and history and ultraviolet, and you can even download in bulk some old information. Air pollution seems to be some new thing there, so many different things that you could use. But I just focused on this one, and each of them have a documentation. So this API doc is a very common thing. Google also has it there, the documentation. It's just here, different examples, and I think it's possible also to see more documentation elsewhere, but it's here. It's as given as examples. So here, this one is very similar, and I'm using this by city name version. So I'm asking the weather in Joensuu in our example, but it's also possible to query by city ID, which is something I don't know what it is, or by geographic coordinates, where you just input the latitude and longitude and you get the number. Zip code also possible apparently. And you can even get for several cities, if you say that you have this region like, I don't know, Eastern Finland, then you might get more cities like Joensuu, Ilomantsi. Yeah, so documentation is there, but let's see how the code works in practice. So get weather in city function is here. A similar key as before, I got it with my own account. The request is different. It's not to Google anymore. It's on this open weather map place. And here we are trying this city request, and yeah, and I also need to include the key here. It's also a get request. Now I'm using this global variable to parse the output. This is why the error with Joensuu and Kuopio was happening. So here I say Joensuu weather column. If I look now at my output, so Kuopio weather column, and now the result here, overcast clouds, it comes later. It comes when the request completes in this onGetWeather function. So those two functions, when I was calling this with Kuopio, it was unsynchronized and causing some problem in the output. I want to attract attention here that before we used this kind of function here, instead of putting a name for the function and then writing the function separately, this always works. So if I move this component from here and I just paste it here, this other function, this will work with no problem. So I remove the name of this function from here. That is how the notation looks like. Let's try it out. So I save it. Yeah, it still works. The reason why I kept it separate is just to teach you more. So this here, I'm not 100% sure, I didn't check the terminology, but I think it's called the lambda function. What it means is that this function is a bit more difficult to debug because it doesn't have a name, and it also will disappear after it is run. So after you run it, the function is not in memory anymore. It doesn't exist. All these other functions that have a name will load and will become part of the memory when you open the web page. This one, it's inline. You don't have to have so many names for things. Like here, on get weather might not be a very good naming for our function, and you might think in your mind, do I really have to give it a name and put it there? I would say it's the better approach. It's more clear and easier to debug. You can now go into your, so if I do this, if I save it and run again, I could always go here for on get weather, search for the function, and now I can put a breakpoint there, for example. Refresh the page, and now this program has stopped in the onGetWeather function, and it's trying to parse this string output coming from server with the weather information. So I could go here step by step and now investigate, for example, weather in city variable, which already contains the result, and so on. If my function is this lambda function, I could still do it here, but I can't find it anymore with the search component because it doesn't have a name. So debugging becomes a bit more tricky, a bit more difficult, and it could be confusing if you don't know what you're doing. Okay, removing the breakpoint, it's not needed, and I let everything run. Is there any question about this weather part? So here I'm using this global variable because here I have the city information inside the function, but when I get the result, I will get it later. It's in this asynchronous time, so after it is done, I will get it. Then here I don't have the city information anymore. I just have the output, which will append our weather description from there. I didn't investigate what is happening with the time, so I'm refreshing. Kuopio weather is always last. Now this is kind of interesting, but also expected.
We are the other time zones here.
Yeah.
That's the reason that we have so little people.
Okay.
So few people here.
Okay. Well, that's not the reason, but good try. So Google seems to be actually getting faster and faster, even with this Timezone API now, as I'm refreshing this page. The weather API is just a bit slower, so compared to the others, it seems to be consistently slower, about 20 times faster than the Geocoding, and 76 milliseconds, 81. Similar speed to the Timezone API, but I'm also calling it later, so that also has a small effect there. And I didn't check the response variable here, so let's preview it. Many things here. So I took in my result from main no, not from here, from the weather component of the response. I took, it seems to be an array of objects, so I took the first element in the array, and I took the description, which says overcast clouds. Possibly this main would have been also good there. So here I'm taking the weather component here, and then I don't know exactly why it is an array here, but it is an an array, and the first element in the array and the only element in the array is containing the description of overcast clouds. So very simple thing what I'm doing, but many other things are here, like the wind. Wind speed is also written there. I think it's quite important. And I think it's also possible to find somewhere wind direction, but I'm not sure where it was. I found it, but before. Anyway, yeah. And you can use also location instead of the city, but the request will look a little different. You need to check here the by coordinates feature. Right. Any questions about this weather stuff? Also, probably this is very useful for those who make the weather app. Yeah. I did get some questions about solar radiation. This for detecting the solar light, the northern lights. I didn't check if it is possible to get. I quickly Googled for such APIs. And I got many of them, but I think they are actually doing something else. So these are real APIs. I tried this Solcast one. It will tell you what is the radiation at a given location, but I think the purpose is not for detecting northern lights. I think that the purpose is for positioning solar panels. So you have the solar panels for electricity. They need to be angled exactly at where the sun is pointing. And depending on your location, this angle might have to change somewhat. So this API tells you if you have solar panels and some robotic arm maybe that moves them exactly in the sun direction, how to what is the angle at your location. So you will find these APIs for everything. I didn't even know this is a thing. But it probably is not useful if you want your app to include also this northern lights detection thing. And I was also asked if they want to do some other feature, if I have some ideas. And I have one. Wind cycling. You don't like wind, or you like wind. It's kind of debatable. So let's assume that that you go cycling this path here. So these are some of my attempts cycling this path. Now, if I tell you that the wind comes from the north in this direction, you would probably want to go cycle the path in this way to avoid this direct facing north wind on this path. So depending on the wind conditions, I'm sure they are possible to get with that weather API. I'm just not going to get now in depth. You could recommend a direction where to go on a track. So if you have a collection of trajectories, you could recommend a trajectory that has the least headwind to the one that you have to cycle like that. And also recommend a direction in which to go, because usually you can go in any direction. So, for example, if the wind is still going like that and you were thinking to go this path, then half of this trajectory is facing the wind. Maybe you wouldn't like half of your time to be directly facing the wind, and you would rather have some wind coming from the side, like if it's north facing wind, then maybe side wind is more tolerable than headwind. So you could consider a much more complicated function, but if you're able to do that, then it's like a 5 at the course with no problems. And you can ask me for help, so that's also something. But anyway, many of these features I haven't seen anywhere, and I think some people could benefit from them. And the wind is not the same everywhere. So the wind in Liperi here might be from the west. The wind here might be from the south. Wind changes very much, especially if you plan to go some very long trip. Like this, I can say I cycled to Kuopio several times, and there were some surprises on the way, like some places with local winds that change, or not to mention the weather. Like had times when sunny in Joensuu, sunny in Kuopio, but raining in Tuusniemi. So weather affecting some kind of plan that you are making. So you can think of an app where let's make a plan, and then you press a button, is this trajectory good if I plan to do it today? And it's going to say that you will have rain here or wind here or so on. So it could be a very, much more than a weather app, but more linked to the Mopsi system. Anyway.
Excuse me.
Yeah.
There were in the solar site there were the format like a JSY. What is this?
Here.
Yeah. It said that developers can send the message with the JSP. Yeah.
I don't know.
Okay.
I don't know all of them, but we can figure out. So let's see. So conversions seem to exist, but what is JSV? I don't know. I hope it's nothing bad. Java structure viewer file. Okay. Well, I guess it's just some other way of formatting, like JSON. CSV is also option. So CSV stands for comma separated values. It's actually this what you see here, values separated by commas. It's also what Excel uses to separate the values in different cells. XML you should already know from Android interface development, and this trajectories have this GPX, which is also an XML. I don't know what this is. I have never seen it before. I don't think it's very popular.
Okay.
But they are options, so you can choose either the JSON or this API. And JSON is quite everywhere, I would say. It's rare that you find one API without it. Okay, let's go back to more examples. Next, I will teach you about this navigation. So I did show before this OSRM. So this OSRM gives you navigation instructions, and now it's going to navigate me from this location here to this location here. Latitude is same, but longitude is a little bit different. I just put some example there. I don't know really where these locations are, but you can check on the map if you are curious. And if I run this here, okay, I have navigation from here to here, and these are points along the way where the geometry changes. So if you are going to draw a curve that connects all of these points, it will fit on your map. So it will fit on the roads inside on the map. let's go to the web page a little bit. I showed this before, so this OSRM, it has this demo. So yeah, basically the points where the road changes are those locations that you see here listed. And the first one, okay, the first one is very close to this 62 here. The reason it's not exactly 6228 is probably because 6228 is not accessible by the road. It could be 1 meter away from the road or something, but this is very close to 61.99. 27.99 is also very close to 28. So this is the start location, and we are heading towards 27.5 because that's my destination, and 62.07 again, it's not exactly that value because I chose them randomly and they are not on the road, but the navigation still gives you some result. Now maybe I can demonstrate a little bit what I mean by this, because sometimes I notice that I know some things very well, and you might not know what I'm talking about. So this is the same tool, but with visualization. So it's exactly the same call. I want to know from here how to get to here. So these are the location changes anytime that the location is different. It is working with OpenStreetMap, so if you use the Google map, it might not appear exactly on the line, but OpenStreetMap has some cycling lanes that are going there. And the start and end locations, they are not exactly on the road, so there is a little bit of compromise happening there. And that's why they are not the same values. Right, so this OSRM project, yeah, it has also documentation and a very large API here with different requests. So requests can give you many different things, I would say. If you check the services, it can give you the nearest service. So this is, if you are at one location, what is your nearest road? It's a very simple thing, but it's used in car navigation systems because in car navigation systems you're always snapped to a road. Your car never appears to be off-road. It's always on some road. You probably have noticed this. It's never on a field if the road doesn't exist. If you go in some place where the road is not in the database, it's still going to snap you to something most likely. If you're really far away, then maybe not. But this nearest service is used for that. The route service is what I'm going to show you. Table matching trip service is solving the traveling salesman problem. It's telling you if you have 5 destinations to visit, what should be the order for you to visit. So it has many tools here, and yeah, even this round trip seems to be an option here if you want it to be a cycle or a path. I don't know everything that it can do, and alternatives. So it might not give you just one path, but it could give you more paths. I don't know how it works, but yeah, so it seems to be a parameter here that you could search up to n alternative routes. Some more description somewhere here. Yeah, like, can't guarantee something to work, but anyway, let's see how the request fares here. So I'm just going to try multiple times. It seems that now my okay, for some reason this time zone request was very low now, very far away. Yeah, Okay. So this navigation and the weather were faster than the time zones. Now you don't know really how to understand this, but just expect that these will not work the same all the time. So the navigation, yeah, let's look at the code first. I forgot. So I said navigate using this two location objects. There are the parameters. So start point, end point. The request looks like this, and this one doesn't have a key, but I suspect that it might be needed. I'm not sure. I can say what we do in Mopsi. We use this, but we have downloaded all the OpenStreetMap data on our server. So we have all the road information on our computer, and we also downloaded this OSRM service. So you can download the entire routing machine. So this stands for Open Source Routing Machine. You can download the program on your computer, compile it, and tell it to use OpenStreetMap streets. So we don't call to this address anymore, we call to our own computer in Mopsi, and then you don't need any kind of key or something like that. I think, I'm not sure if it's needed here for just calling their server, but probably it has some limitations. You can look at their documentation. And again, this is a GET request, and printing the output. So let's see what the true output is. I'm only putting these coordinates of the geometry in the output, so these coordinates, but my response is bigger. So if we preview the response, it has the routes, it has this geometry object here. It tells you the distance. I think this distance, it means 52 kilometers. I think it's in meters. I believe, otherwise it doesn't make sense. It tells you duration. So it tells you how long it would take to go there, to go this distance. And this might be seconds. I think it's seconds, maybe. I'm not sure. Seconds means quite a lot, 2 hours. We can read the documentation and figure it out. But let's see a bit more first. So the geometry, these are the coordinates that I'm printing out, these ones from there. I'm not sure what weight means, and these waypoints, exactly what they are, because I was not interested in them. Also, I'm not sure what this is. Yeah, what does it mean? You don't know? Okay. But I don't know why it is there, and why is there a waypoint there. But anyway, let's look a little bit at the documentation. So root service response. Doesn't seem to describe exactly what it means here. Maybe responses here. So you might get a message like something is too big, like they might not allow you to query as long as you want. Root service, so the response. No. So documentation is not very good. I would like to know what is the measure for the distance? What is the measure for the time? So usually those would be here saying like seconds or. Oh, okay. it says for the table service, but this is not the routing service. It says for the match service, tile service. Okay, yeah, it's here. So the route object, the result distance is meters, and duration, estimated travel time, number of seconds. So it might be that the roads that are going there are very slow roads, and that's why you need such a long time. So yeah, it's very possible. So here it says that the distance is 52 kilometers. You might need 2 hours to go there if it's a really bad road condition, but it sounds unreasonable. So I would take it with a grain of salt, these different numbers. But it's what you get. So you could argue better than nothing, and the distance should be much more accurate than the time. So you could also consider how long would you need for this distance and have a speed in mind, and then calculate the duration yourself. So yeah, you can do many things with this. But this, yeah.
So, sorry, about the map, what that uses? I guess that uses map where is the roads.
Yes,
okay?
yeah.
And what kind of format in electrically is that?
So this OSRM, I believe it uses the OpenStreetMap. Let's see. Yeah, it uses the OpenStreetMap here, and the format for OpenStreetMap, I think we talked a little bit before. If you press this export button, it's XML data, if I remember correctly. I'm not sure. Does Lahari know? So it might be XML data. You can download it for different countries, and you can also download from a specific region. Like here, you can select a different region. But if you look at this this web page, you should find some place where you can download also everything and by country. But I haven't looked there. But it's XML. I remember doing it before with you. So let's take a very small part here. I don't want to load too much. And I export it, and it says OSM format for OpenStreetMap, but it's really an XML format. So it's going to say different bounds of different objects that are there on the map. This tag can name, yeah, this Honkaniemi is there. I actually know the place, but it's very big, and these ways are different paths that you can take there in that small region. So there is a walking path, and there is a cycling path, there is a driving path near to that also, like this kind of mountain biking trail in that region. So it contains a lot of information, but you need to know how to parse it. And OpenStreetMap is open, so the documentation is there. It tells you what all of these things mean, but I don't plan to go too much into detail. So it seems to be also these descriptions here, like human-made descriptions, what it means, what the path is like.
Yeah.
Yeah.
Could be that way that the waypoints from the response are these ways to tell us to how to write or draw the map, the road.
To draw the map?
Yeah, if the result was that we can draw the street map, the way to the A to B.
No, if you want to draw the result, so if you want to see the path from A to B, you just draw these lines that I'm showing you here. Yeah, so so one thing you notice here is that my file that I downloaded from here is very big. But here on the map you see very few things. You see Honkaniemi here and some path there, but the file is huge because the map here doesn't display all the information that they have. Only displays this more minimum information. If it would display everything, think about displaying there approximately 60-kilometer long circular trail around the city of Joensuu, both in urban and rural areas, for example. Where would you put that text? It is there, it is associated with this path, but no point to draw everything there. So yeah, so this is what you need to display, only that, and you can use any map layer that you want. You can use Google Map, you can use these open layers, or yeah.
Okay, and that means that TSP using these coordinates to calculate the best way.
TSP.
Yeah, if there is the algorithm used there.
So this is not TSP, this is just shortest path. This is like maybe like Dijkstra's algorithm. For the shortest path algorithm, TSP is they also offer TSP. So here in the documentation it says they also have the TSP service for the trip service. This is for multiple directions.
Okay.
So here you just have directions from, like in my example, from A to B, but the TSP would have more of them, and it would also tell you the order.
But I mean that the algorithm uses only these coordinates.
Yeah, only this is the input, but the algorithm uses also the big map that is in their database. So yeah, okay. Now finally I show you some more things that we can do with Mopsi. I'm going to...
Do you want to give a little break?
Maybe, yeah. Let's have a 10-minute break now and continue with some more things.
Yes, please.
Okay, great. So meanwhile, what I did is I removed all our work. So now there is just this boring addition there. Let's remove also this. Oh, you're welcome. I will activate it again before the lecture ends, so that you have an example with everything there. But I want now to demonstrate some other thing that it might interfere, because these times are different, so I don't want you to be confused about what is happening. Yeah, okay, so I'm going to load the trajectory, a route that I did myself, a cycling path. No, not a cycling path, a skiing activity. It was something like this. Maybe something like this one, maybe not exactly that one. So skiing roughly 25 kilometers. Doesn't show there, but anyway, this place is called Pärnavaara, so I called this Parna, TXT, there. Let's see first what it looks like, and then I will explain what everything is. So it's doing three things. First of all, it's loading into a global variable, this groute variable, a route from this text file, Parna TXT. If I open it, it's not GPX. It's just every line, it has three components, latitude, longitude, timestamp, latitude, longitude, timestamp, and so on. the reason why we don't use GPX in Mopsi, except for this transfer there, is that it's bigger. So writing this file in GPX is going to be about 3 times more characters than just writing it in this plain form. Because the XML syntax is also there. So I just give an example here. Yeah, so I go here for this trajectory and I download it as GPX file to see how it looks like. If it opens anywhere. Sorry?
There was a thing, you can't open it just now.
Oh, okay. Let's try again. So, because it looks like this, so I have the latitude, I have the longitude, and the time in a little different format. You can see how much extra characters are there. So, if you think about the file size, it's going to be bigger, and for no really good reason in this case. That's why we use this simpler format. But anyway, so we are loading this file into memory. I have put on the server 2 files. So one is this Pärna.txt and one is this Kuurna.txt. So Kuurna.txt is another trajectory that I have made at some point. But first we start with this one. And I call this function process route from text file. So from that text file, it's going to load it. It's going to do a post request to get the file. And when it's done, when I have the string, the text in that file, I call this parse route text function. This one will create my route array based on this text and put their individual points with their latitude, longitude, and timestamp. So I'm processing that file every line and then splitting by the space. So nothing too complicated. I don't know if you need to worry much about understanding this, but reading this file from here into our typical objects that we worked with. So now that this groot variable contains all of these points in our typical naming convention, like latitude, longitude, timestamp. I could have this file be JSON file instead, and then just parse it, and no need for this this other function. But I just put something together using the raw root files from Mopsi and this small function here. So I'm loading it into this groot variable, and I'm saying that it has been loaded into this output that you see here. Now, to calculate the length, I don't use any distance measures. I'm calling the server. So I'm calling the server in this compute route length on server. I updated that Lamad API from yesterday that shows the sum of the 2 numbers to also get the route length. So I'm giving it the whole route, okay? And it's going to output the length of the route. It's going to say that the route has this much kilometers. So let's see how this request looks like. The end is 25.8. I guess I use the floor function here when, yeah, I use the floor function there for some reason. Maybe not to have such many decimal places. And my headers, they are big. So now the headers, what I send to the server, is a huge amount of information. I'm sending to the server the request type to get the route length, but then I'm sending the route, which is all the points in the route. So this is going to mean upload time. I have to send the route that I want the statistics for. okay? So if I go to the timing, this request takes somewhat time, but to send the request here, you see it starts to accumulate. It's not just sending one location, now I'm sending the whole trajectory. And this one has many points. It has 2,486 points. So more information to be loaded. All right. Of course, I don't have to send the request for the route length. I created this measurements.js a while ago. It has our get distance, our haversine function that we did before. Okay, and I added 3 new functions. This is the most important. So with the route, I go between every pair of points, every 2 points in the route in order, and I calculate the distance between every 2 points, and I add it to the total length. So it's a very simple function to calculate the route length. I don't need to ask the server for this kind of process. Your phone can handle it. But in this example here, I'm getting it from the server just to demonstrate. And after it, I call this one, I also call a more complicated function. It says segment route on server. This one is going to do something a bit more complicated. It's going to segment the route into different segments. So it's saying that starts by stopping, running, stopping, running, stopping, running, stopping, running, stopping. If you look at the interface here in Mopsi, you see it's actually what is happening here. It's this visual output that says what are the segments of the route. So it's a method that automatically segments based on the type of movement that you are doing. And it's telling you the movement type. Now, this is a more complicated function. I'm not going to get into how it works. It would take too much time, and our purpose is just to use things that are already existing. But let's see a bit about the statistics here. 1.36 seconds. No more milliseconds. This is seconds. Waiting time for the server to reply is 1.23 seconds here. Look, when I refresh the page, there is nothing there. It's coming later. So this processing, figuring out what kind of movement is happening, it's already something that if you would implement on your mobile phone, it's going to drain battery, it's going to be very difficult to calculate if our very powerful computer here is still having this much trouble there. So already this kind of feature is more useful to have it elsewhere. The other ones are more like demonstration, like this route length here. But this one is already worth to call elsewhere. The same with all the other functions that we have. So now I'm going to reactivate all the other calls, and this is going to end our example for today. I commented them out before because you see the route gets loaded here, and then it has 25 kilometers here, and then at the end it has the segments here. So it starts to combine with the other requests that we have due to the timing offsets, and I wanted it to be more readable before. Is there any question about this? Because now what I want to do is I want to go to our tracking app, and once we have a route in our tracking app, I want to teach you how to segment it and to figure out the transportation mode and to display it on the map differently. So last practice that will take probably 15 minutes if I'm lucky. I haven't prepared for this. But, any questions so far? One more thing I would say, this result from the segmentation, it contains more information that what is displayed here. It says for each of these types, stopping, running, whatever they are, it's not just a name, but each of them contain not just the type, but also all the points in order. So what you see here on the right is a subroute. It's the part of the route that is associated with stopping. So it's going to be very easy for me to display all of these routes by just loading the result from here. I don't have to fit any timestamps or anything. I just will display many segments next to each other. So if this is clear now, I will. Okay, because I don't want to end too roughly. I want to also talk a little bit about a few other things that you should know. First of all, there is a survey for a job opening in summertime. I should have prepared a bit more for telling you about this, but let's try. So I'm going to add the link to the survey here in the source code. You have also links to the other APIs here that we have used today, so if you want to learn more. What is this summer work? You will need to have some skills, either a master student, PhD student, some programming experience, and some general development skills, some algorithmic skills. So we are interested how much you do that, how much you know about these. We are also interested how well you will do at the LAMAT course. Because this Impro project, yeah, let's put also the link to that, so just a second. Yeah, so this Impro project, it's about optimizing the healthcare and social services in northern, I think in North Karelia. In North Karelia, and we are part of this optimization system. So it's going to be, I would say, most similar to what you know is the traveling salesman problem. It's going to be the problem that the population is aging. More people are going into urban areas, and we want to know where to put hospitals, where to make, how to change the structure so that it will cope with these changes in population. And we will need also a visual interface for this, something like a simulation. That what happens if you put a hospital there, or what happens if you remove something from there in terms of costs and in terms of quality. So it's quite a complicated problem, but it has really big applications, and we have many tools that can be used to solve this. So if you think it's something that you want to participate in, fill in this survey, and then later on, I think probably maybe June, I'm not sure, then we will figure out who is going to do that. But yeah, so it's going to start as summer work, so it also would mean that you are here in the summertime. And I'm not sure about duration, but at least during the summertime, and if things go good, then all the way to the end, the project is going to exist for 3 years, and possible to extend to 6 years. And one more thing I wanted to mention. Yeah, Oh yeah, so and it will be a paid position. I think you can ask if interested about that value. It will depend if you are master student or PhD or what you are, and yeah. So you can ask me more questions on email about this, and of course fill the survey with your skills. So that's something that I planned to tell you about. And oh yes, Mopsi, if you go to the machine learning group here at UEF, we have these Mopsi tools. Mopsi has some other APIs also. For example, this polygonal approximation API. It loads a route, like this black line here on the map, and it outputs this red line that is significantly less points. So if the route has 556 points, the red one here has only 13 points. And the way we use it in Mopsi is that if I'm zooming out here, it doesn't matter anymore if I display the red line or the black line. It will look the same on the map. And the more I zoom in, the more points I need. In this case, 25 points looks again like the main route, but I'm loading much less information. So only these points here, instead of all of these points here, look almost the same on the map. So this reduction API is something that you can, anybody can use if you are interested. And we also have a similarity API. So route similarity functions, there are several of them. I would say let's use this more real example. So we invented this one, this CSIM method. It says that these routes are 33% similar based on these cells that you see on these grid cells that you see on the background. The red ones are common, the others are individual ones. But there are many other methods. This one is based on string similarities. This one also. Many different ways to measure similarity of trajectories. And we also have API for that. So the API is elsewhere, I think. It's actually here, but you can ask me if you are interested in it. So this paper has the link to this tool, this visual tool, but API is also here. So you can ask for a measure. You can specify the measure, the similarity measure, and also give a route as a parameter. And you will get response like what is the similarity, how long it took for the server to calculate, and so on. So the route is now this GET request here in the link. So these are just more examples of APIs and things that we have built, and they are more research oriented. But some of your applications could benefit from that. So ask if you need any help with those. Okay. So now let's see what we can do here with this Super Tracker application. I'm going to do a lot of quick things, hopefully. Yeah, I close the examples and move now to this Super Tracker. I copied it to Super Tracker 2. So I changed my mind about the Android. The new codes for the updated version will be this version 2. It will have also the segmentation, and I will make new links for that. So you can still access the old links later on the web page. I will do this during this week, so it's not there. The new code for Android is not there yet, but it will appear this week. And I just copied this Super Tracker to Super Tracker 2, so at the moment they are almost the same. almost identical. So these ones from here. My location is different because on one tab I was using this fake location and the other not, but it doesn't matter. They are the same. And now problem is that my collection is empty. So okay, yeah. So this for some reason this browser doesn't respond to me. Okay. Okay, now it works. So collection is empty. This is a small problem, but because I want to test something with real data. So instead of simulating to get real data, I'm going to put these two routes, this Pärna route and the Kuurna route, I'm going to force them into my memory of the device. So I'm going to force them into the memory with these, what I label here as test functions. They are what I showed you before, loading root from the text file and parsing the root text, and then segmenting the root on server is going to be the function that we will use. It's the same as before, but instead of printing the result normally as text, I'm going to try to do something more visual here. So I enable now these two test functions, and I try to load them into memory. So now the collection is empty, but if I call this load root from text file, and I take this Pärna root into memory, what happens is after the root is parsed, the result goes into our g_collection variable as a new root. So it's now there in this collection. And I'm going to go back, and I'm also going to load another root, this Kuurna root from the text file again. And now collection has two elements. It has this one here and this one here, ones that I mentioned also before. So in the network tab, they are the two text files that we worked before with, at least the Pärna one we worked before. I just loaded them into memory and I put them into this collection so that I have a root here. I'm not simulating with the emulator because it would need 2 hours to get a root like this in the simulation. So I had to hack it and be able to test it somehow to get this real information here. So yeah, but now when viewing this collection, okay, when viewing this collection, I'm loading the root, but I would like to see if it has any segments, if it is different in different parts, like we saw before. It has some stopping segments, some running segments, and to show them differently. So to do that, we will go to this controls file and go at the function for show the collection item. So here we are now making a polyline with these different values and with a root, and fitting the map bounds to the bounds of the root. So when we are changing the map, also moves that. But I want to call this segment root function that we saw before also. So let's see how that one looks like. I just call this segment root on server, and I give it the root from our collection as a parameter. So that's it. I'm going to refresh the page. Oh, I didn't store into cookies the two roots. Sorry about that. I have to load them again. Now they are loaded again. Right. Right. And then I have to save them somehow. So the save function is somewhere. Save tracking is here. I just want to put the values into the cookie. If I ever refresh the page, yeah. So if I ever refresh the page, it doesn't work. I'm not sure why.
Maybe check Geocollection, is it empty as well?
No.
Maybe the cookie has a limit, the size limit.
It's possible. Yeah, it's possible. Okay. For this demo purpose, then maybe we don't do that. We might also postpone this demo because it seems to take longer than expected. But yeah. Anyway, there's no rush to finish this now. So you might be correct that there is a limit for the cookie, but I would expect to see it. To have a warning message or something coming because of that. These are
the size?
Sorry?
Because of the size?
Yeah, it could be the reason, but I don't think they are limited. I don't think the cookies are limited based on the sizes. I might be wrong. So yeah, so this JSON stringify of the collection seems to work. Makes our roots very much text there, and they are very big. So I do think that Bilal is right. For some reason, this set cookie doesn't work. But anyway, now when I'm trying to load it, it seems that okay, I get an error because I'm trying to run this to segment the route here over HTTP, but it should use HTTPS because the web page is also HTTPS. So I think I will just have a code here that loads this Pärna route, and then I go to my collection, and now I'm not getting that warning anymore. And if I go to the network tab, after I loaded the route, I got this server call that says, okay, stopping, and here are some points, and running, and here are some points, and so on. Yeah, so I think if you want to leave, then that's fine, but I will probably stay maybe 5 more minutes. I want to visualize these points somehow on the map differently, and then we go away. So sorry for taking a bit extra time, but yeah, some unexpected things here. Okay, so here we have our results. So our results string is here in this at this time, and I want to get the object from this. So this is what happens after we get the result from the segmenting of the route, and our object variable is well, let's see.
Excuse me, one question.
Yes.
is this means that you have the Urna and Karna text files, and you can use these to initialize the system.
Yes, I'm using that as a hack, as a way to make the application have the roots even though I haven't tracked them myself. Otherwise, I can't test without waiting for the simulator in Android to do this route for many hours. So.
Yeah, but main thing to save the roots is to use the cookies in this application.
Yeah, but it seems to be a problem with the cookie saving if the route is too long. So I might have to rethink this and update it in the future. Okay, but now this object coming from the server, I printed it here. So for each of these types, I have different number of points showing here, and the type is showing there, and it's inside this server object. So if I go back here to the code, I have to do object of server to access these this array of 9 moving types, and for each of them I want to display them on the map. So I'm going to do a quick code here. So move types will be there, and now for all of them, so for each move type, I want to draw the points. So draw route segment. I'm going to put here, so this function doesn't exist yet, we will make it. It's going to have the move types of I type. So this type is going to be one parameter saying how the segment will look like, and the points are a separate parameter. So the 2 parameters for this function, type and the points. And I'm going to write this function here. So function draw route segment, type and points. And now I'm going to look at the controls here to see how I did the drawing of the other route. So I just put the value of the polyline to be this path here. That I'm giving it there, but my polyline already exists, and it was defined in the main function here, like that. So I'm going to reuse this code. Okay, and yeah, and I will need to make a new segment every time. So a segment is going to be created to create a new polyline. It's going to put it on the map. The color, it will depend on the type, okay? So now I'm going to decide the color. Let's say I'm going to switch based on the type, and I'm going to say if it is stopping, I want the color to be red and break there. I'm not sure if the syntax is correct, but and if it's running, I'm going to make the color to be green. And maybe if it's something else like cycling, I'm going to put the color to be blue. So now the color is a variable here. Instead of having a fixed color of red, I'm just going to have it change based on the type. And the path, I'm going to put it to be these points, which is the second parameter. This is really fast prototyping here, and probably there will be some problems, but let's see what happens. And I'm going to put the weight higher, maybe 4, so that it covers the root on the background. This is just for demonstrating purposes. And yeah, so now collection is empty again. I'm loading this Pärna because the cookies doesn't work. I'm pressing it, and I get some error. So, all right, I get error because sorry.
Also the points.
Yeah, this points I think is not in the proper format.
Yeah.
What is the proper format? So here I'm setting the path like that. Okay, let's debug this function and figure out. So after this function works, we can stop. I'm going to put a breakpoint there and enter the collection again. It took some time before this happened because the server had to do the segmenting. Now the type is stopping. This is just fine. It's going to figure out the color. And then here at the segment, makes a new polyline. The points is an array of 43 elements, and they, oh. It could be that this is not a number, it's a string. Let's check. Usually JavaScript is very permissive to these kind of things, so I'm a bit surprised. So not enough. Yeah, it's probably that. So I'm loading the root here, but the value is not a number. I don't know why it's coming as a string from the server, but
when you added the G collection, you didn't parse it, right?
I think I just
Do you cast it?
okay, just one second. I want to see if the server is indeed giving me back. Yeah, so the server is giving me back these as strings instead of numbers, and I think there is no parsing really needed. This is a problem. So I'm going to do something that you haven't seen yet, but I go to the server and I see whatever is happening in here in the segment root function. Yeah, so I think it is like that, but you can correct me because I'm not sure how
I
this.
think it's like just
It just flowed in the parentheses.
Okay, something like that.
Yeah.
We see. This is PHP now, so it might be. Yeah, and this is timestamp, but it doesn't matter. So let's try again. Okay, something happened. Good. So now my response doesn't have these string values here for the latitude and longitude, and something happened here. There is a little bit of red at the beginning, so this is considered by Mopsi to be a stop. Okay, some green segments, and probably we will find more red segments if we look carefully. Like here, another stop. So a very small example, but and not very good interface, and also very glitchy in the sense that now if I go back, these lines are still there. So I need to figure out how to update the interface to remove those lines, because they are not anymore using the polyline. They are multiple polylines that I am now losing because they are only defined in this function. So I have to find a way how to manage the collection. But I will do these off screen to make the so next updates that I will do to this super tracker will be off screen, and you will still see comments in the code about how it works. But the functionality for this basic thing, how to get that is that. One more example, so just to see how it works with the other route, because I have it there. So now instead of this Pärna, in addition to this Pärna, I'm going to put also this Kuurna track and load the collection again. So this is, now I have routes overlapping each other. So I have thicker routes here. I'm not sure if you noticed. And on the right, now I get this one, which is the server says bicycle. So no color here because I wrote cycling, but oh, sorry. Yeah. So again, refreshing the page, loading the Kuurna route first now and the Pärna the second. Collection, this one now is blue, it's all blue. I don't think it has any stops. And the second one, again, this one took longer because it's a longer route. And this one is green and it has those different values, and it has the problem of the other one still being there. So I have to make the interface adapting to these, and progress indicator is needed now, because it's doing that processing for the segmentation, but I don't know how long it takes. What happens if the route is 10 times longer? It might take maybe even up to a minute. I don't know what the complexity of the algorithm, so I need to tell the user that something is still going on if you want to wait for it. So small updates, but yeah. So sorry for taking 10 minutes of extra, but
no problem.
Yeah.
That was very interesting.
Okay, great.